Hey YouTube, it's Abhay here. Today we'll be solving maximum subarray problem from Leetcode. So let's go through problem statement. Given an integer array nums, uh, find the contiguous subarray containing at least one number which has largest sum and return its sum. So we don't need to return subarray itself. We need to return sum of subarray. So there are few takeaways from this problem statement. So there are three takeaways from this one. So subarray should be contiguous. So it's like continuous subarray. So like from 2 to minus 3, it's one subarray. We cannot take like 2 minus 2 1 and then minus 1. And subarray should have at least one element. And if you go to the constraints, array is already like at least one element, so that got it covered. So if there is array is only one element, we can just return it. So let's go through some examples. So let's go through this example. For this example, if you see, there is one minus one, so there are many possible sums. So one sum can be like individual elements 5, 4, minus 1, 7 and 8. Then we can add two elements like 9 for this one, and this can be 8, this can be 15, and this can entire array can be 23. And I think 23 is maximum, that's why the output is maximum. So to solve this problem, there is a standard algorithm, Kadane's algorithm. In that algorithm, we take two variables. So one variable contains maximum sum. So one will contain max sum. So this will be sum of entire array, max sum, sum of entire array. So this will be our answer. Like this will be like we will going through the array and we'll keeping track of maximum sum. And the second variable will be that will keep let's call it running sum. Running sum, or we can call it sum as sum now. So this will be sum till current element. We can call it sum so far. So by default, maximum will initialize with either the first element or integer min, and we'll keep track of the sum now, and we will keep comparing with maxsum. And if maxsum is less than sum now, we'll just update maxsum. Let's write code for this one, then we can have better understanding. So let's create these two variables. So int So as of now, I'm just initializing both variables as integer minimum, and we will loop through array ones. So we will, okay, I think we need to like add some now to 0, since we will be adding number into this one. That was my bad. So now let's do some now plus 0 num side. So we'll be like adding current number, if sum now is greater than max sum, we will assign max sum sum now. And there will be case like if sum now is less than 0, since on the first case when we will going through 0th element, and maximum will be assigned like, if assume there is all the negative numbers, in that case like first element will already be assigned to maximum, so we don't need to like keep adding to sum now. We can just reset sum now if value is less than 0. We'll go through one case for this edge case. I'll just add all the elements as negative, and we will have better idea for this one. We'll just reset this value. So let's go through the first example. So that is, I'm just initializing all the values. So for I is 0, sum now will be -2, and since we will compare like int min and -2, so we will have like, let's start I equal to 0 over here. We'll keep updating these values. So for this, like sum now will be -1, sorry, -2, and then we'll compare like -2 and int min, so we'll take max of it, -2, and we can update this if statement also if we want, because there is inbuilt max function in the C++. Max. So this function return maximum of 2 numbers, so let's use that one. And then for one, so, and in the last step we are resetting some now value, so this will become 0, and then for I equal to 1, sum now will be 1, and we'll compare, we will take maximum of max sum and sum now, so that value will be 1. And in next step, and we'll reset, no, we won't reset this value. So in next step, sum now will be -2, and we'll compare, since 1 is greater, so maximum value will be same. And in next step, this will be, so since sum now is less than 0, so this value will reset. And in next step, we will take 4, and then we will compare these values. Then 4 is maximum, we'll keep maximum as 4. Then there is -1, so somehow will be 3, and I'm not updating the I value, but we are going through the array. So this, then next value is 2, so somehow will become 5, and maximum will also become 5 since 4 is less than 5, and then somehow will be 6, and maximum will be 6, and then there is -5, then somehow will become 1, and the next step somehow will become 5 since maximum sum we found through the array is 6. So this looks good, but there is one case for that. We added some now less than 0, and we are resetting those values. So that was covered in previous case also, but there is one more possible case. It's like nums is all negative numbers, so -2, -1, -10. So in this case, maximum is n12. Now is, so first we will add like some now plus 0th element. So for I equal to 0, it will be -2, and we'll compare. So maximum will be updated. So we need to reset the sum now value now, because if we keep adding, since the next number is negative, so this will become -3, and that's not an ideal case, so we'll reset sum now. Next step we will like add -1, so it will become -1, and maximum will become -1, and then it will become -10. So I think that's what it covered, and this case was also covered when there are like negative numbers in the array for this case, but still I wanted to add one more example for this one. So our code looks good. Let's try to run with the sample test case. Okay, we are not returning the answer. So okay, let's try to submit it. So it looks like work. So if you see, like, there is runtime 79% faster than the C++ solution, and memory usage is also less. So we can also go through like complexity for this one. So for space complexity, since we are using two variables for any n size array, so let's also go through like time and space complexities. So for n size array, we are using only two variables, so that's like order of 1, since the space we are using is not directly proportional to the size of array. This will be like space complexity, this will be space complexity, and time complexity will be order of. The reason of order of n is since we are looping through entire array only one time, so for n size array we'll be looping over n time, and like 100 time for 100 size array will be 100, and 10 to the power 4 it will be 10 to the power 4. So this is the time and space complexity for this one. That would be it for this question. If you like the explanation, please like the video and subscribe the channel. Thank you. Bye.